Hi, hello, welcome friends to our Smart Easy Mac YouTube channel. So we can continue our technical discussion on thermodynamics subject. Previously, the first four chapters of the thermodynamics has been covered. So viewers who haven't watched our previous videos, please don't worry. The description link is available in the description box. You can make use of it. In this video, we are going to discuss a small topic, second law of thermodynamics. So it will be more justifiable if I start the session with our channel special one, the brain teaser. So which is more powerful, scattered energy or concentrated energy? So we might have performed a fun experiment in our school days by focusing the solar energy from the sun through the convex lens to the paper. At the end result of the experiment, the paper catches fire. This implies that the solar energy, if scattered, has less power, whereas if it is concentrated to a particular point or a region, it will be more powerful. So here we comes what is the second law of thermodynamics. The limitation what we have faced in the first law of thermodynamics will be rectified in second law of thermodynamics, because the second law of thermodynamics itself is referred as qualitative law of thermodynamics. It differentiates between high grade energies like work energy, potential energy, kinetic energy, and low grade energies like heat energy. According to second law of thermodynamics, the thermal energy at higher temperature has more significance when compared to the same amount of thermal energy at lower temperature. Next comes the thermal energy reservoir, which has infinite heat capacity medium. There are two thermal energy reservoirs. The first one is the source. It is a thermal energy reservoir which can give large amount of thermal energy without undergoing any temperature change. And the second one is the sink. Sink is a thermal energy reservoir which can absorb large amount of thermal energy without undergoing any temperature change. Then comes the parallel statements of second law of thermodynamics. The first one is Kelvin-Planck statement and the second one is the Clausius statement. What is Kelvin-Planck statement? It is impossible to develop a cyclic device which develops work while exchanging energy with a single reservoir. Here in this diagram, there are two reservoirs. The first one is the TH represents the temperature at the source region and TL represents the temperature at the sink region. And the circular one is a cyclic device which absorbs QH amount of heat and rejects QL amount of heat. And the work done will be given by the formula QH minus QL. And the efficiency of this cyclic device is given by the mathematical equation eta is equal to 1 minus QL divided by QH. A machine which violates the Kelvin-Planck statement is known as perpetual motion machine of second kind. Here the energy exchange happens between the single reservoir only. Also, the work produced will be equal to that of heat supplied, which is practically impossible. Next is the Clausius statement. It is impossible to develop a cyclic device which transfers energy from lower temperature to higher temperature without any external energy input. This is the representation of a refrigeration model. Here QH and QL represents the source and the sink region, whereas this cyclic device, here the refrigerator, which requires a work input and it extracts the heat of QL from a TL, so sink region, and supply QH to that of source region. And what is the speciality of this two Kelvin-Planck statement and the Clausius statement is that violation of the Kelvin-Planck statement will lead to a development of an engine which do not require any fuel. And the second one is still more interesting. Violation of the Clausius statement will lead to development of the refrigerator which do not require any electricity to operate. By hearing these two facts, we will have our fingers crossed for any young minds to break these two statements and solve the global issue what we are facing today. Next comes the ideal cycle, the Carnot cycle. Why I am telling this is an ideal cycle is practically this cycle doesn't exist. And it has through two isothermal process and two reversible adiabatic process. And the efficiency of the Carnot cycle is 100%. The graph here represents the PV diagram for the Carnot cycle. And the important Carnot principle is that the efficiency of an irreversible engine cannot be more than the reversible engine operating between the same temperature limit. So the second one is the efficiency of all the reversible engines operating between the same temperature limits are same. And the points to be remembered in this Carnot cycle is that efficiency of a reversible engine is a function of temperature limits under which an engine is operating. Also, the efficiency of the reversible engine is independent of the working fluid, whether it may be an oxygen or nitrogen or helium or ammonia, whatever may be the working fluid, it is independent of the efficiency value is independent of that of working fluid. So this is about second law of thermodynamics. If you like this video, please like, share and subscribe our channel for early updates. Thank you.